Hello guys, I will show you something today on SAS program. So here I want to show you some model assumptions by which we will make some assumptions using a multi-predictor linear regressions using different variables. So let's get started. So I'll show you the file import data of the open program. We can go to this PC. My work. The lab too. So I've just opened this one. So I'm using this as a for the work today to show you the different multi-predictor linear regression model. So first I'll create a library name lab2 as lab2. In my computer I show the pathway here. This is the pathway by which my computer will see or SAS see where my library is located. So hit the button, then go for the data. So which data I am trying to analyze. So first you have to write down the data, then the library name. My library name is lab2, then dot, then my new data file. So this is my new data file because underscore is better to copy your original dataset because so that your original dataset is like preserved. So I'm setting a new dataset underscore a. This is my original dataset. So you have to give first library name, then new dataset name, which one is like working dataset, then set. This is the original dataset. So I'm setting a new dataset name by putting set my library name and dataset name. So SAS call them as a dataset, and this is the library. Okay, we are running this. So here in the log window you can see what are the things you have done. Like there were 400 observations read from the dataset. The dataset underscore a, which one is my working dataset, has 400 also observations and 22 variables. So also note that data statement used total process time, so what are the times they took. Okay, come to the next. So this is our model. So we use the procedure GLM, generalized linear median, linear mean, generalized linear mean, probably GLM. This is the one tool we used in SAS. So you have to keep the data name first. You have to indicate the data. So first write down the library name, then a dot, then our working dataset, then working dataset, then plots. So we are going to see the multi-predictor linear regressions. So the data linear regressions, we have to use these commands equals plots equals to diagnostic residuals. So in the bracket you have to write down the unpack. After that you have to give a semicolon. So this is the end of our first statement or data statement. Then we have to write down the model statement. Like model, this is our outcome variables. So here we are using three different predictor variables. First one is meals, second one is full. So that means meals means the credential of free meals. This is the free meals. Full means full teaching credentials. This is another variable. The mobility means percent of first year in schools students mobility. So we have three variables. These are the all explanatory or the independent variables. Then you have to give slash solution SS3 because our outcome variable is a categorical variable. That's why we're using this slash solution SS3 then semicolon. So you have to remember this model statement. Then we have to run, then quit the statement. Then we hit the button. Here you can see the residual plots for FE100, FEI00. So this is our dependent variables. As we said, like FE100 equals the academic performance of the school in 2000. So academic performance in the school. Okay, so we can see there three different variables. Full, this is the another independent variable, this is the premiums is the first variables, then percent of first year in school, the third variable. We can see the in the points in the model we can see points seems symmetric around the horizontal line, and no pattern, so linearity appears to be made. So it seems like there is a linear relationship between these two variables. Anyway, so we are seeing that correlation between residuals and predictors seems to be around 0, and no pattern of homoscedasticity appears to be made. So there is no pattern of the homoscedasticity. Sorry, this is a difficult term, so I'm learning for the first time. Homoscedasticity appears to be made here. So in the x-axis you are seeing in the x-axis the predicted value. In the y-axis we are seeing the residual value, that is means actual value minus predicted value, y minus y hat in the y-axis. Okay, anyway. So if we also say that considering the plots of residuals y minus y hat and values of x for each independent variable, so there does not seem to be systematic patterns in these plots, so linearity and homoscedasticity appears to be made. This is the residual fit spread plot. This is the another one, histogram, Cox D. So these are all the things we have run in the log here. So in the model run. Now I'll run the next one. Next command is to see another regression diagnostics. So you'll see now we'll consider Libera's points, outliers, and collinearity using the results from the multipredictor linear regression with three different variables: full, males, and mobility, as we did it earlier in the earlier command, and mobility as independent variables and academic performance of the schools in 2000. So this is the AP100, academic performance of the school in 2000 as an independent variable. So we'll consider this and we'll run this variable again. We run the commands. So here the residual plots. So what we can see, residuals by predicted for AP00, predicted value, studentized residual by predicted AP100. So here we can see the outlier and Libera's diagnostics. So what are the outliers? Okay, we say the plot. This plot is showing that which points are outlier. Also, Libera's points are both by color. Libera's points both by color. Also investigate points of interest further using footprint before making decisions to keep or remove. So you can go to our next command is footprint data std res and variable. This is our dependent variable, other three independent variables where ABS are equals to less than 3, more than 3. So you can run this. So we can see that AP they give us the different values for the regression diagnostic. So we can see the cutoff for studentized residual does not return any potential influential points. Potential, if you look into the first 5 observations until 107. So the cutoff standardized residual does not return any potential influential points, but the cutoff for Cook's did as. So we can use these both methods to assess influential points. These both methods. So finally, if we examine another regression diagnostics, the GLM procedure again, we'll have to see that for these three variables, we have to see the type 1 tolerance and type 2 tolerance. If the type 2 tolerance, like for all the independent variables, are less than 0.1, the values is less than 0.1, that is indicated multicollinearity may be present. So if it is like more than 1, so there is no multicollinearity. If it is less than 0.1, then there should be multicollinearity. So we can also see the tolerance tolerance by seeing the BIF. So BIF means variable intercept something. So that is the regression diagnostics for today. Thank you very much.